Hello and welcome to Greiner Bio-One Talks. My name is Anna-Maria Šimundić and I'm the director of the Global Medical and Clinical Affairs Department. And we will talk about urine analysis today. And I have a very special guest with me here, Timo Kouri. Timo, welcome.
Thank you, Anna.
So Timo Kouri is a medical doctor and a docent emeritus at the Department of Clinical Chemistry at the University of Helsinki. From 2018 to 2024, Timo chaired the EFLM Task and Finish Group Urinalysis. And as such, he was actually the lead author of the 2023 EFLM Urinalysis Guideline. With his research on urine analysis and pre-analytics, he contributed significantly to the field through numerous publications and international collaborations. And I think there is no better person to discuss urine analysis than you, Timo. So welcome once again, and thank you for accepting my invitation.
You're welcome.
The first guidelines, so the first version of the guidelines were published in 2000. And then last year the new version was published. The revision was published. So could you tell us what is new and what this new revision actually brings?
Yeah, the reason to make this new publication was the technical development first, because lots of automation has taken place, and also we have got more new legislation in terms of ISO 15189 accreditation, and also some practices, including pre-analytics, may have been developing since the last version.
Yeah. So what are major quality requirements in urine sample collection?
It's an easy question. We have written
not an easy answer.
We have written 3 chapters on the new guideline on this pre-analytics. And just to summarizing it, I wrote down some of the points. First is the cooperation with medical staff or clinics to get medically justified requests for urine analysis and motivate both healthcare staff and patients. And then you need computerized data interfaces to deliver that information to laboratories. And next critical step is the patient. It's important to focus on patient because she or he needs to be involved in delivering or donating a sample, which is opposite to the blood specimen. So there are several details that are important when you want to get a proper midstream specimen. And then third one is the technical collection, where you need instructions, discuss with patients, and then, of course, how to deliver that primary specimen to the secondary tubes and preserve them after the analytics. And all of these have details and need cooperation with hospital or ambulatory care units and laboratories.
So what are the most critical pre-analytical steps, or maybe most common pre-analytical errors in urine collection?
In the guideline, section 3, we started with a quality indicator of fraction of polymicrobial growth or mixed culture in bacteriology. That may be up to 50% of all urine specimens you are getting if you measure them in bacterial cultures at 10 to the 4 colony-forming units per ml. So proper midstream collection is the question number 1. You have to reduce that. And the second one is if you are able to select or collect elective patient urines, you need to standardize other parameters such as diuresis, water intake, and then exercise, avoiding menstrual periods and other details.
So even though collecting urine may seem like a very simple procedure for patient, the truth is that it is not, and there can be, many pre-analytical errors could occur while collecting the urine. So how do you make sure that you get appropriate sample volume and that you that all pre-analytical steps are done correctly in terms of the patient instructions?
You have to interact with patients more carefully than it's been the tradition. It's not enough just to give a paper, do this, and follow the images. You have to discuss with patients what are the personal problems. Is it possible to give that specimen in the laboratory, or do you prefer having that at home in your own piece? And did you have difficulties? And then after collection of urine, you need documentation. What did happen in practice? Did you succeed, or did you discover any problems? Because if the patient is motivated, he or she will bring her or his reality into the discussion. And then if you document that, then the doctor can use that in the interpretation of results.
Mm-hmm. And is order of draw in urine collection important?
It's perhaps less important than people think, but if you start, like in blood collections, you want to make a series of orders. The most important thing is that you want to avoid contamination from your fingertips in the same way as from your skin or collection area. And that's why you collect first the microbiology specimen and then the chemistry specimens, where the microbiological contamination is not so important.
And let's talk about the sample volume. So it seems to me that we still actually require too much of urine for analysis. So what is, in your opinion, the minimal sample volume for?
Actually, the volume of urine is not a big issue because you get more of it easily. It's less important than the blood volume, and that's why perhaps the test strip manufacturers have kept the size of the strip to the large enough for even of visual reading, and then you usually need 10 ml tubes. An other issue is also the mixing of the specimen before analysis that occurs in particle counters. And then that's why, because the urine tubes go in the same automated tracks than blood tubes, the volumes have been standardized in practice to the same volumes and blood specimens. But for analyzers, you can manage with 1 microliter for bacterial culture, another 1 microliter from manual feeding for automated counting, but test strips also by pipetting, but that is not the structure of the instruments.
Yeah, well, urine may be easy to get, but if you think about the waste management, and I think the lower we go, the less waste we create, right?
Yeah, well, yeah, that's true. In principle, yes.
Yeah. So then in that respect, thinking about the volume of urine, what about 24-hour urine? Is this a sample that we still need? And then if so, how to handle the pre-analytical?
Yeah, the need is dependent on the idea that urine volume is dependent on water excretion, and the concentration of whatever analytes or particles you have may then vary at least tenfold. If your urine osmolality starts from 100 milliosmoles to 1000 milliosmoles per kilo. And then the way to balance it is to take a period of collection, for instance, the 24-hour collection, independently on the volume. The other option is to use an analyte that is reflecting the water excretion, such as creatinine. But because the random urine may vary depending on the disease, you sometimes need both of these. And typically, for instance, for renal stone or urinary stone formers, it's still questionable which one is better for incidental renal stones if they are recurrent. Generally, for chemistries, we are moving from 24-hour collections to single-body specimens.
Acidification of urine as a sample, is it necessary, and if so, for which analytes?
Quite many analytes used for analysis for recurrent stone-forming metabolites need acidification. There are then also options that need alkalinization, such as uric acid. That's why you first have to collect the specimen, then measure the pH, and then divide the specimen into aliquots for both processes. And then if you also measure particles or albumin, you need a third type of preservation for that.
And that brings me to my next question. So how would you say is stable urine as example? And maybe which parameters are less stable? And then, do we need to stabilize urine for those parameters?
It's best to evaluate that separately for each of the analytes you are measuring. But we have experience that most chemical analytes are stable at pathological concentrations, typically at least overnight, so that you can collect the urine at home and then come to the laboratory for the acidification or other preservative purposes. While for urine particles, you have to start preservation, hopefully best at home or immediately after the collection. Then the other option is that you deliver the single sample already in the lab if you don't have the preservative at home.
And which preservatives would you recommend?
The guideline describes in one table several analytes and preservatives, and you have to look at that carefully there, depending on the analyte.
Which parameters, in your view, might be beneficial for testing in urine, which are not actually routinely tested today?
The need is organ-specific measurand or analyte detecting kidney disease as early as possible, because plasma creatinine is not optimal one, and urine particles related to kidney disease are typically present at low concentrations. We are actually missing biochemical marker for kidney marker that would reflect the damage. The closest one at the moment is renal tubular epithelial cells, if you can measure them at low concentrations. But I would like to have a better one. Albumin and alpha macroglobulin and so on are functional markers. They are not damage markers.
And my last question to you, throughout your outstanding career, what is maybe the most memorable pre-analytical moment that you can think of?
Yeah, I had two in mind. The first one is related to how to describe to people how to collect the actual urine specimen to be understandable both for women and men. And we incidentally got a young man who was a good drawer. He was doing Finnish military service, and he was hired by Tampere University Hospital Laboratory to draw instructions to patients by after explanations by freehand, and then transferring them into computerized images. And those images have been used since 25 years and translated into several European languages and even Arabics and so on. And the second one, so this was a major impact if you at that drawing into your toilet at home or at the healthcare unit. And the second one was the discovery we made in Tampere at that time, that it's possible really to preserve the urine overnight to avoid collections in various vessels and try to cool them down in refrigerator-cooled styrofoam boxes and transfer them then next 20 or 200 kilometers overnight.
How did you find this out incidentally?
We had some available tubes that were tested, and we had the procedure to discover the changes in reflectances, reflectometers, and also automated particle counter at that time in 1990s to analyze repeatedly with acceptable imprecision the particle counts.
Well, thank you very much for this insightful discussion about the urine. Thank you for accepting the invitation, because as I learned, you plan to retire, and this is actually your last podcast that you accepted. So thank you very much on behalf of the audience. I hope, dear colleagues, that you have enjoyed this podcast as much as I did.
Yeah, I wish you also all the best to your spectators of this broadcast.